Hello and welcome to our lesson on calculating the surface areas of 3D shapes. In this lesson, we'll expand on our previous knowledge by learning how to calculate the surface areas of various 3D shapes using the intuitive notion of nets. This will make it easier for you to visualize and understand surface areas from a practical perspective. We'll begin by reviewing what nets are and how they represent 3D shapes when laid out flat. We'll then move on to using these nets to calculate the surface areas of several shapes, such as pyramids and rectangular prisms. Then we'll examine shapes such as spheres and cones where instead of nets, we have to use specified formulas to find their surface areas. After this, we'll apply our knowledge to different examples, ensuring we can confidently calculate surface areas in practical scenarios. In our previous lessons, we've established a solid foundation by recognizing different kinds of 3D shapes like cubes, spheres, and cylinders. Understanding different representations of 3D shapes, including isometric drawings, orthographic projections, and nets. Calculating the area of 2D shapes such as squares, rectangles, triangles, and circles. With this foundation, we are now ready to explore the concept of nets and how they help in calculating surface areas. This technique is particularly useful because it allows us to break down complex 3D shapes into simpler 2D components, making the problem more manageable. For example, if you're tasked with finding the total surface area of a gift box for wrapping paper, understanding and using nets will enable you to determine the exact amount of paper needed, ensuring there is no waste. Let's get started. Let us start by reviewing nets. Nets are a crucial tool that helps us deconstruct three-dimensional shapes into two-dimensional shapes. A net is essentially what you get when you unfold a 3D shape into a flat layout, showing all its faces. This makes it easier to calculate the surface area because we can work with familiar 2D shapes. Take this cube, for example. As we've seen in the previous lesson, we can unfold it to its net, which is made up of 6 squares. Moving on to calculating surface areas, let us start by examining a triangular prism. It consists of 2 triangular bases and 3 rectangular faces. We can unfold this triangular prism to its net. When laid flat, its net includes 2 triangles and 3 rectangles. Now suppose we want to find the surface area of this shape. We can calculate the area of each 2D shape in the net and then sum them up. Let us take a closer look at the net. Suppose the triangular bases are equilateral triangles with a side length of 3 centimeters, and the rectangles are 3 centimeters wide and 4 centimeters tall. Starting with the triangles, we know that the area of a triangle is half times base times height. We know the base, but we need to find the height. Using Pythagoras' theorem, 3 squared equals 1.5 squared plus the height squared. Therefore, the height is equal to the square root of 3 squared minus 1.5 squared, which equals 3 square root of 3 over 2 centimeters. Knowing the height, we can plug this into the triangle area equation to give an area of 9 square root 3 over 4 centimeters squared. The rectangles are more straightforward, each with an area of 3 times 4 equals 12 centimeters squared. We need to add up the areas of 2 triangles and 3 rectangles, so the surface area. We plug this into the equation, which comes to approximately 43.8 centimeters squared. Let us now consider a square-based pyramid. We can unfold it to its net. When laid flat, its net includes 4 triangles and 1 square. Now suppose we want to find its surface area. Again, we can sum up the individual 2D areas shown in the net. Suppose we have that the base is a 4 by 4 square and the sides are equilateral triangles with side lengths of 4 centimeters. Starting with the triangles, pause this video and try to find the height. Refer back to the triangular prism example if you need a reminder. If you got 2 times the square root of 3, then you are correct. We can now calculate the area of one triangle as half times 4 times 2 square root of 3, which comes to 4 square root of 3 centimeters squared. The square is straightforward, with an area of 4 times 4 equals 16 centimeters squared. We have 4 triangles and 1 square. We add up the areas of each of them, so the total surface area comes to approximately 43.7 centimeters squared. A sphere's surface area is more complex, so we use a formula. The surface area of a sphere is calculated using 4 pi r squared, where r is the radius of the sphere. For example, suppose we have a sphere with a radius of 2 centimeters. Its surface area would be equal to 4 pi times 2 squared, which is 16 pi centimeters squared. Finally, let's look at a cone. As we unfold the cone, we can see its net consists of a circular base and a sector of a larger circle forming the lateral surface. To calculate the cone's surface area, we need to consider both parts. The area of the circular base is simply pi r squared, where r is the radius of the circular base. For the lateral surface, we will use the equation pi rl, where r is the radius of the circular base and l is the slant height. Note that the slant height L is not the same as the height H. If in an exam you were given H, you would need to use Pythagoras' theorem to find L, so make sure you are careful with this distinction. The derivation of this equation is not something you need to know for your exam, but is relatively straightforward. We will not go through it here, but you can research it if interested. Combining the two areas, the formula for the surface area of a cone is pi r squared plus pi rl, where r is the radius and L is the slant height. Suppose we are given this cone with the labeled lengths. First, we need to figure out what those lengths are. The 3 centimeters is the radius of the base, the 4 centimeters is the height of the cone, and the 5 centimeters is the slant height. Therefore, plugging in the radius and the slant height into the equation, we get that the surface area of 24 pi cm squared. In today's lesson, we explored how to calculate the surface areas of different 3D shapes using the intuitive notion of nets. We began by understanding what nets are and how they help in visualizing and deconstructing 3D shapes into 2D components. We then applied this knowledge to specific shapes such as prisms and pyramids. Finally, we learned how to use formulas to find the areas of spheres and cones. Understanding and applying these techniques equips us with valuable tools for solving practical geometry problems efficiently.